Okay, so thank you very much for the introduction and the warm welcome, and thank you all for being here. This is not the title of my talk. Don't worry, it's just I come here from a company to you at university, so I thought it's kind of expected from me to tell you how to make a lot of money. So I sat down, thought about it very much. I don't think I had any really grand ideas. The best way to make money with LLMs is to be NVIDIA. Admittedly, it's perhaps a bit late to start with that. The next best thing might be to offer cloud services. It's actually not too late for that. There are some startups who do that now, particularly looking at AI workloads typically. Still, it's quite a huge investment. You need scale. It's not so easy. But there are other ways to do that. It's a bit more complex, perhaps, or harder to explain. But a lot of companies, I think, are starting to become successful with that. And that's the third option. Enhance productivity of your users. By that, make them use your services, your platform more, and then indirectly generate revenue. And that's one path that also we are going. Okay, so I'm Martin Flechl from Dynatrace, and the main topic today will be domain-specific language generation. I will not say much about Dynatrace, don't worry. We are in the observability business. We have one product, but that one product really has a lot of different components, and I happily talk to all of you guys over all the details, over a coffee or dinner or whatever here, but not today. The most important thing, all these different things that you can see here, what they do is they all collect a lot of data. And we are not Google, so we don't collect the data for us. We collect the data, it's customer data, and we collect it for our customers so that they can learn something about themselves, security-wise, business-wise, infrastructure, application services, and so on. Now, data, we all know, you're all in data science, data is very powerful. If you have a lot of data, it's even more powerful, but you also have to be able to make sense of that data. Otherwise, a lot of data doesn't help you a lot. The way that we typically, our customers can access, at least at the lowest level, their data is via queries. We have our own query language at Dynatrace, the Dynatrace Query Language, very original name, but at least people can remember it. You can do then lots of nice stuff. The most obvious thing is a dashboard like that. Each of the tiles here would be one query, but you can also do other fancy, interesting things. I will not go into detail here. That's all great. The downside of this is not everyone likes to write queries or is able to write queries, and even if you are, it's sometimes very time-consuming, very complex to really get it right. So what we offer now is a new service. It's in the context of what we call our Davis Copilot in Dynatrace. One of the features that it has is this text-to-query generation. So you put in natural language, English, German, Chinese, whatever you want, as long as our models understand it. And you get out a query, and even the query executed, and so on. We will see all that. So let's start with what is SQL? I mean, you can think SQL, it's different, but that's more or less the same thing in the end, of course. You may have a question on your mind, like the one shown here. I would like to know my hosts ordered by memory consumption. That's an observability-related question, so that fits here. You can write a query. In this case, it looks like that. This is a relatively simple query, so that's still okay. It's not trivial. You need to know a lot of things. Is there a laser pointer? No. Anyways, you need to know, of course, the syntax, what are comments and functions and so on called, but you also need to know your field names. You need to know that memory consumption, you have dt.host.memory.usage. I mean, this is not something intuitive or that follows from somewhere. You need to know it or find the information somewhere, right? Yeah, but if you succeed, then as a reward, you get, in this case, a nice visualization. Of course, you can also directly access the records. You can do all kinds of things with that. Now, what about this Davis Copilot that I told you about? Again, we have the same question. Just this time, we directly enter this as a question to Davis Copilot in natural language, here in English. And what then happens is exactly the same as before. The query itself is generated, and then it's also executed, and the result presented to the user. So that is, on the one hand, attracts users which do not want or are not able or whatever to write queries. But it's also a time saver for people who would be able to write this, but instead of 3 minutes, it takes them now maybe 3 seconds. Okay, how does it work? What does it take to write such a query successfully? We can start, what does it take for a human, but obviously an AI system needs access to the same kind of information. So some of these queries are quite complex, so some people believe what you mostly need is magic. I understand where it comes from. If you have like 30 lines of code for a query, you might believe that, but obviously it's not true. There's no magic involved. To write a query, you need to know something about the language, and you need to know something about the data. So when it comes to any kind of language, even natural languages, you need to know something about grammar. For DQL, it would be called syntax. For queries, you need to know something about vocabulary, so what is stuff called, commands, functions, and so on. And for the data side, you need to know where does it reside, in which tables is it, what is it called, what is the schema, oopsie, and all that information. And all of this we also need to be able to provide to our AI system. I will show you now, this is already live and running. It's in our product. There's even like a demo workspace, so you can all try it if you want. The way it works at the moment, I'll just walk you quickly through that. User provides an input, that's obviously the starting point. Then we check, is this a question we want to answer at all? In this case, it would be, is it related to DQL, to our query language? Then we continue, is it about Donald Trump or about Brad Pitt or about our competitors? Even worse, then we break, then we don't continue. We just tell that to the user. Okay, then the second step, this is already called to a large language model to decide that. In the next step, we devise a plan for the query. That's like one line for each line then of the resulting query, which identifies relevant comments, field names, and so on. It already takes in some information from the outside, from a vector database that makes sense here, that is semantically similar to what the user requests. Output is then this plan, and this finally goes into the last step where the query is then actually generated. So there's again more information pulled in from databases to be able to fulfill the task, plus also examples. So in terms of few-shot prompting are also pulled in, and not just any, but again semantically matching to the user query. And then if all goes well, the result is presented to the user. Now, if you think that's complex, then I think you're right. It is complex. It's quite involved, lots of different bits and pieces that need to fall together and that depend on each other. What we've been doing, so this is in the product, what we've been doing in the last couple of months is to devise a new way to do it, and that looks like that, a lot simpler. The main difference here is that we use our own large language model. Above what we used was any large language model, in this case OpenAI, GPT-4. Now we train our own model. This learns a lot about the syntax, about commands, functions, and so on already during the training. So we don't need to feed it huge prompts. We still need to feed some information, like information that we don't know at train time, like what the schema or the schema-like structures of customers are, for example. But it simplifies the whole thing, of course, at the cost of training and hosting this model. And I will tell you a bit more about that now. So this model, when we started designing that, first we sat down and discussed what do we want to achieve, what are the requirements. We wanted it to run on a single GPU and not even a P100 or something, but on a like medium-sized. We want it to be fast, at most a few seconds per call. This we achieved by going into a range of 7 to 8 billion parameter model, which is 2 to 3 orders of magnitude less than GPT-4, for example. Yeah, we do a few tricks. It's not so important if you have not seen that before. Of course, we still want the results to be accurate. That's the most important. Otherwise, the rest does not make sense. We achieve that by having a large and diverse training set and also a verification step of the query, of the resulting query. I'll say more about that shortly. We wanted to be able to adapt to customer-specific schemas. That's a tricky one. For that, we run something periodically, a so-called schema discovery. I'll also say more about that. I hope that time will allow. We wanted to be able to adapt to how our language, our query language, evolves, because all the time we keep adding new commands, new functions, for example. This we achieve by retraining regularly, and that's only possible if this is to a large degree automated. So we have an automated retrain pipeline that is then triggered every few weeks to produce a new model. And of course, we care about privacy and security. We heard a lot about that already in the previous session. Okay. So how do we do that? The setup for the training is relatively straightforward. First, we need some data to train. That's the most intricate step, and I'll have an extra slide on that, so I won't dwell here now. We train the model, or retrain if it already exists. We evaluate the model. For that, we need a test set. We also create new test set whenever appropriate. So for example, if the language changes, if there's something new. And if the model passes, if it's good enough, then we deploy it. Yeah, I think there's nothing surprising here. The interesting thing is really the data part. So here what we do to get to data, we start scraping queries that internally other Dynatrace employees have used, because we also use it. We use our software also ourselves, right? That circumvents a lot of privacy and so on problems. So we collect a huge number of queries. We bring them in a structured form eventually in a syntax tree. We deduplicate, so that doesn't only mean getting rid of exact matches, but also things that are just very, very similar, like only some string names different. We cluster them, k-means clustering, so that then we can take from each cluster a certain number of examples so that it's kind of balanced, that we don't get something overrepresented. Yeah, that's also a tricky part. When we collect the queries, we always redact them in terms, we remove email addresses, credit card numbers, passwords, whatnot, and of course in a very conservative way, a lot more than might be needed, even though it's internal data. And we somehow have to fill in useful values again, because otherwise the query is not invalid if you just have these placeholders everywhere. That's very tricky, but yeah, I will not dwell on that here in the interest of time. And then the final step is that we generate a prompt that matches to that query. For that, we use a large language model. That's, of course, also not a simple task, and it's necessary to provide a lot of extra information for it to get right, and some quality assurance and so on. But in the end, what we get is then a large training set. So we put in the query, we get out a prompt that looks, for example, like that. Yeah? Okay, and then we have our training data and also test data. Lastly, inference is also not just trivially invoking the model. We have at least two non-trivial steps in there. One is this schema discovery that I've already mentioned. Imagine the user asks, show me errors of my app. And the correct query for that would be what's written here, fetch this events, blah, blah, blah. Obviously, you cannot get directly from this prompt to this query. You need some more information. And that information would be something about the structure of the customer data, what is typically called a schema. Just our data warehouse is schema-less, so we don't call it that. But in the end, what you want to know is the structure of the customer data. You want to know that the app of the user is called easy travel, that the errors are stored in a field called failure, for example. Yeah, you get that information, semantically matching again, and add it to the prompt, then the model is able to produce that. Finally, we have this verification step. So what happens here? Imagine the query is just not right. There's a typo here. There's an S too much. If we find such a query, we validate each query. We check if it executes. If it does not, then we correct it in an automated way. That's using a mixture of our verify and of our autocomplete endpoints. With that, we try to get it to something that is valid. In the best cases, we can actually correct it, like in this other example. In slightly worse cases, we can still provide a valid query by just truncating it, removing the parts that are wrong. Then perhaps we only fulfill about 90% of what the user wanted, but that's still a lot better than just not providing an answer. Okay, and then the final important step is evaluation. In the LLM space, that's a highly non-trivial task, because there's typically not exactly one correct answer, right? How to do something. Even for queries, you have different ways to express the same underlying query. We do that with a mixture of metrics. One, the simplest one, is validity. Does the query execute, or what's the fraction of queries that are actually executable? That's very nice and easy to interpret, but also it doesn't tell, by itself, it doesn't tell you much, because the model could always just produce the same trivial query, and it would look like it's perfect, even though it's totally useless. Yeah. For that reason, we also evaluate query accuracy. So how similar is the query to the ground truth query? We do have a special thing, a special edit distance, but I don't have time to go into details here. And lastly, also execution accuracy. So we execute the queries, both truth and generated, and compare how similar the result is, the records that we get back. We also evaluate, of course, latency. That's more trivial. We look into these metrics in various dimensions, so not just as one average number that might look like that. And then we can identify if one of the dimensions is, for example, how complex is the query. Then we can identify points where we are weak, where we have only 60% perhaps executability in this case. That's medium complex queries about entities. Whatever that means is not so important. And then we can simply inject more training data, for example, for that tile, for that configuration, and hopefully recover some of the performance. Yeah, I'm almost done. I'll go over that quickly since I already got the 1 minute sign. Yeah, one important thing is we can always use our own stuff or use big providers from the US. And in many cases, it's actually for a company, it's a lot cheaper in the end not to build your own stuff. But if there is something very specific, like we want it for our query language, then this changes. We actually can see some added value from it. Yeah, I'll go quickly over that. It's not so important. One thing we learned is when you build something, and we've also seen this in other projects, what's most important if you want to improve is to focus on the data. The first important thing is data. The second important thing is also data, both quantity and quality of data. And then you have lots of other things, then maybe models and so on. But the data is in the end what really matters. Yeah. Okay. Yeah, so I'm at the end of my talk. The way we produce money, at least, is we make our users comfortable with using our platform more and more. They don't have to pay for generating the queries, but they pay when they execute queries. They always have to, with or without GenAI. And by that, we then create some revenue streams for us. And lastly, just about myself and my company. So at Dynatrace, we have thesis programs, internships. We're also interested in research collaborations, even also in lectures, guest lectures. So contact me, get in touch if any of this is of interest to you. Thank you very much.
Yes, thank you very much again, Martin Flechl. Are there any questions?
So, thank you very much for your talk. It was quite interesting. I have one question regarding the model. So, I'm guessing you did not start from scratch.
That's correct, yeah.
Okay. So, can you tell us about what are the backbone of your model or the starting point, maybe?
I mean, we investigated all models where the license allows us to use it then commercially. And main candidates were things like Mistral and Llama, now also distilled DeepSeek models, for example. In the end, we don't see so much difference after the fine-tuning between the performance. Currently, the best one is Mistral, actually, so a European model, which is nice, not by choice, but it really, for our context, it works very well. But the differences are very small. After the fine-tuning, they all perform very similarly.
Oh, so just by using LoRa's or fine-tuning and whatever, you basically remove the bias or the base training from the models?
Yeah, not really the base training, and we also rely on that base training to some degree because it requires also general language understanding skills and so on, right? But we can at least teach it what we needed to do. We do see some difference. For example, the Llama models, they're very difficult to train. They seem to have very strong instructions already, right? That they try to adhere to. So it's not really exactly the same, but in the end, I mean, a lot of models are at a very similar level, which is good for us. If one of them disappears or the license changes, we can switch to a different one that doesn't hurt us.
Okay, thanks.
Okay, maybe this, we had a question here in the front. Maybe this is the last question since we're running out of time, sorry.
Oh my God, thank you. So now, how is it going with the user adoption? Do your customers use it a lot, or are they hesitant?
No, they do use it. I mean, Dynatrace, we have a small number of customers, but very big customers, typically the biggest companies in the world. So, I mean, the whole user, we don't have millions of users to start with, right? But we see a strong increase since we've released it. More and more companies are using it, and we see, I mean, we are now at thousands of requests per day. That's, for us, that's a very significant number and still increasing significantly.
Thanks.
Okay, then thank you again very much, Martin Flechl.
Thank you. Thank you.